In this video, we are going to go over simplifying rational expressions. I have listed here your 4 steps that you are going to follow every single time. Your first step is you still need to find your excluded values. Since we are still working with a fraction, we know that our denominator is not allowed to equal 0. So we first have to find our excluded values. Then step 2, go ahead and completely factor out your numerator. Write that down. Step 3, completely factor out your denominator. Write that down. Then step 4, you're going to look to cancel, or in other words, now you're ready to actually simplify. So let's take a look at an example to see how those steps actually work in practice. So if we have this example here, 21n being divided by 35n minus 28. First thing we need to do is we need to find our excluded values. We learned how to do that in the previous video. So your excluded values was when you took your denominator and you set it equal to 0. So my 35n minus 28 I set equal to 0. From there, we went ahead and we solved, or we got our variable by itself. So to do that, I'm going to add 28 to both sides. That's going to leave me with a 35n is equal to 28. Now, what's keeping that n from being by itself is that 35. So I'm going to divide both sides by 35, leaving me with an answer of n is equal to 28 over 35. We have to look to simplify that fraction. Both of those are divisible by 7, so I can go ahead and simplify that fraction into a 4/5. So I know my excluded value is that n is not allowed to equal 4/5. That was our step 1 for simplifying. We found our excluded values. Now we need to factor out my numerator. Well, in this case, 21n doesn't factor anywhere, so we have a 21n in the numerator. We're going to factor out our denominator. What can we factor out of a 35n minus 28? We can factor out a 7 from both of those terms. So that would leave me with a 5n and a minus 4. So now we've completed step 3. We've factored out our denominator. Now we need to look to simplify. So what we're looking at is I'm looking at this 21 over 7. They are both divisible by 7, so they kind of essentially cancel each other out in a way. Or in other words, another way to think of it is we are dividing both the 21 and the 7 by 7. So that leaves me with my answer of a 21 divided by 7 gives me a 3n left at the top. And at that bottom, that 7 divided by 7 canceled out, so I ended up with a 5n minus 4. There was my simplified answer for my rational expression, and I have to include my excluded value that n cannot equal 4/5, and both of those would be my final answer to this equation. Sorry, this expression. This first example was pretty straightforward and the factoring wasn't very complicated. Let's look at a problem when our factoring is a little bit more complicated. If we have this expression, k minus 8 over a 3k squared minus 16k minus 64. Our first step when we're simplifying this is still to find my excluded values. So to find my excluded values, I have to go ahead and factor this denominator part out because I'm setting it equal to 0. So I have a 3k squared minus a 16k minus 64 equal to 0. In order to solve that, I have to factor it. So this was one of our problems where we took our a times our c. So 3 times the negative 64 is going to give us a negative 192. And then I'm going to look for factors of that number that add together to give me a negative 16. So factors of negative 192, well, we have a 1 and a negative 192. We have a negative 1 and a positive 192. We have a 2 and a negative 96. We have a negative 2 and a positive 96. We have a 3 and a negative 64, or a negative 3 and a positive 64. None of these add together to give me a negative 16 yet, so I'm going to keep going. Well, it's divisible by 4, so I get a 4 and a negative 48, or a negative 4 and a positive 48, or I get a 6 and a negative 32, or a negative 6 and a positive 32. Again, all of these multiply together to give me negative 192, but so far they're not adding together to give me the negative 16. So we keep going. What's my other factor? Well, it's divisible by an 8, and you would get a negative 24. And that right there is going to give us the negative 16. So we finally found the factors that we wanted to use. So we're going to rewrite that middle term. So we have a 3k squared minus 24k plus 8k minus 64. Now I did that so I can factor by grouping. Here I can factor out a 3 and a k, leaving me with a k minus 8. The second grouping I can factor out an 8, leaving me with a k minus 8. If we did this correctly, these terms right here should be the same. They are, so I get a k minus 8 and a 3k plus 8. Both of those are equal to 0. So when I have two things multiplied together to equal 0, I set them both equal to 0 and solve. So let's go to the next slide to give us some more room. We're still trying to find our excluded values. So I have a k minus 8 is equal to 0, and I have a 3k plus 8 is equal to 0. And that first one to solve, I'm going to go ahead and add 8 to both sides. That's going to leave me with my answer of k is equal to 8. And on that second one, I'm going to subtract 8 from both sides. That leaves me with a 3k is equal to negative 8. And that to get that k by itself, I'm going to divide by 3 on both sides. So I arrive at my final answer of a k is equal to negative 8/3. So those are my excluded values right there. I know that k cannot equal 8, and k cannot equal a negative 8/3. We're going to use that in our answer at the very end. So far we've completed step 1. We found our excluded values. So we can go back to our original problem. Our step 2 was to completely factor the numerator. Well, my numerator is already factored. It's going to stay like that. Then I need to factor my denominator. Well, we're in luck because in the process of finding our excluded values, we factored it. So we found right there was my factored form of the denominator. So I don't have to go through all those numbers again. I can just kind of steal that work that I've already done. The factored form of 3k squared minus 16k minus 64 is a k minus 8 and a 3k plus 8. Now we've got step 1, 2, and 3 all completed. We found our excluded values. We factored our numerator. In this case, it was already factored. Then we factored our denominator. Now our last step is to go ahead and look to simplify. Well, if we look at this problem, in the numerator we have a k minus 8, and in the denominator we have a k minus 8. They divide to equal 1, so they essentially cancel out, leaving me with my final answer of a 1 over 3k plus 8. And my final answer, I also needed to include my excluded values. And we knew from the next slide there that the k cannot equal 8 and the k cannot equal a negative 8/3. Those were the values we found here. I'm just going to apply them to my final answer over here. So final answer right here. Okay, let's take a look at another example. So in this example, we have 27b plus 36 all over 18. So again, same steps that we've been following on the previous two. First, we need to find our excluded values. Well, your excluded values are to set your denominator equal to 0. So 18 equal to 0. Well, that's never going to happen. So what does that mean? Never going to happen. So that means we have no excluded values. We finish that step. Then we need to go ahead and factor our numerator. Well, if we look at our numerator, 27b plus 36, well, what can we factor out of both? We can factor out a 9, leaving me with a 3b plus 4. Because 27b divided by 9 gives me 3b, 36 divided by 9 gave me that 4. Step 2 was done. Now we have to completely factor our denominator. Well, my denominator is already factored, it's an 18. Now we can go ahead and take a look at that 9 and that 18. We can simplify that. They're both divisible by 9, and that would put a 2 at the bottom. So our final answer here, we have a 3b plus 4 all over 2, and we have no excluded values. Here is our final answer. So it is possible to have no excluded values. Let's look at another example. So in our fourth example, we have an x minus 8 over a 7x squared minus 56x. Again, we're still following the same steps. So let's find our excluded values by setting our denominator equal to 0. When I set that equal to 0, now I look to factor. I can factor out a 7 and an x, and that's going to leave me with an x minus 8. All of that is equal to 0. So now I set each one equal to 0. So 7x is equal to 0, or an x minus 8 is equal to 0. In that first one, I'm going to divide both sides by 7, so I get x is equal to 0. In the second one, I'm going to add 8 to both sides to get that x is equal to 8. So I know my excluded values are that x cannot equal 0, and x cannot equal 8. Step 1 is done. Step 2 was to factor my numerator. Well, x minus 8 is already factored, so I copy it down. Step 3 then was to factor my denominator. Well, we're in luck. We already did that over here. So I have a 7x and an x minus 8. Step 3 is now done. So now all we're left is the last step to go ahead and simplify. If we look at that, in the numerator we have a x minus 8, and in the denominator we have an x minus 8. That divides to equal 1, so we can cancel those out, leaving us with a 1 over 7x. And the other part of my final answer is that x cannot equal 0, and x cannot equal 8. And here is my final answer. Let's look at another example. So here we have 21r squared minus 27r all over 15r squared plus 27r. The steps have not changed. Our first step is to find your excluded values. So I set my denominator equal to 0. So 15r squared plus 27r is equal to 0. Now to go ahead and solve, I'm going to go ahead and factor. I can factor out a 3r, both of those. That's going to leave me with a 5r plus 9. All of that is equal to 0. Now I have two things being multiplied together to equal 0. So I'm going to set each one separately equal to 0. And solve from there. Here I'm going to divide by 3. So r is equal to 0. In the second one I'm going to subtract 9 to both sides to get that 5r is equal to negative 9. Then divide both sides by 5. so r is equal to negative 9 over 5, sorry. So those are my excluded values. Now I can move to step 2, to completely factor my numerator. Well, in my numerator, I can factor out a 3 and an r. That's going to leave me with a 7r minus 9. Step 3, factor out your denominator. Well, we already did that when we found our excluded values. Here was my factored form. So I can copy that over. My factored form, I can factor out that 3r, leaves me with a 5r plus 9. Now I can look to cancel. I have a 3r being divided by 3r. That's going to divide to equal 1, so it cancels out. So we're left with a 7r minus 9, all over a 5r plus 9. And we have to include my excluded values. So we need to say that r cannot equal 0, and r cannot equal a negative 9/5. And here is our final answer.